Welcome to this comprehensive guide on reflection in Kotlin. In this video, we'll explore one of Kotlin's most powerful features, the ability to inspect and manipulate your code at runtime. Reflection provides runtime type information, also known as RTTI, which allows your programs to understand their own structure while running. This capability opens up a world of possibilities for building flexible and dynamic applications. Let's dive in and master the Kotlin Reflection API together. So, what exactly is reflection? At its core, reflection is the ability to inspect and manipulate your program's structure at runtime. Think of it as giving your code the power to look at itself in a mirror and understand what it sees. With reflection, you can inspect classes and objects to understand their structure. You can access properties dynamically without knowing their names at compile time. You can invoke functions at runtime, even if you don't know which function you'll need until the program is running. And you can discover type information about any object or class in your application. These capabilities make reflection an essential tool for building frameworks, libraries, and dynamic applications. Before we can use reflection in Kotlin, we need to set it up properly. Unlike many Kotlin features, reflection is not part of the standard library. It's provided as a separate library that you need to add to your project. To add reflection support, include the Kotlin Reflect dependency in your project's dependencies block. Simply add implementation followed by the library identifier in quotes, org.jetbrains.kotlin Reflect. Once you've added this dependency and synced your project, you'll have access to all of Kotlin's reflection capabilities. It's important to note that keeping reflections separate from the standard library helps reduce the size of applications that don't need reflection features. Now let's explore K-class, which represents a runtime reference to a Kotlin class. K-class is the foundation of Kotlin's reflection system. It provides a way to work with class references dynamically at runtime. To obtain a class reference, you use the double colon syntax followed by the class keyword. For example, string double colon class gives you a K-class reference to the string class. From this reference, you can access useful information like the qualified name, which gives you the full package path and class name. You can also obtain a class reference from an existing instance. Simply use the instance variable, followed by double colon class. This is particularly useful when you have an object but need to discover its type at runtime. K-class provides several powerful members that let you inspect a class's structure. The simple name property gives you just the class name without the package path, making it useful for display purposes. The qualified name property provides the fully qualified name, including the complete package path. The members property returns a collection of all class members, including properties, functions, and nested classes. The constructors property gives you access to all constructors defined for the class, allowing you to create instances dynamically. You can also check class characteristics using Boolean properties. IsData tells you whether the class is a data class, while IsAbstract checks if the class is abstract. These members give you complete introspection capabilities for any Kotlin class. K-property allows you to access and manipulate properties dynamically at runtime. When you have a class with properties, you can obtain a reference to any property using the double colon operator. For example, if you have a person class with a name property, you can get a property reference by writing person double colon name. Once you have a property reference, you can use it to read values from instances. The get method takes an instance as a parameter and returns the property's value from that instance. In our example, nameRef.getOfPerson would return the value of the name property, which is Alice. This dynamic property access is incredibly useful when building frameworks or libraries that need to work with objects without knowing their structure at compile time. When working with mutable properties declared with the var keyword, you get additional capabilities through K-mutable property. This interface extends K-property and adds the ability to modify property values at runtime. Just like with immutable properties, you can obtain a reference to a mutable property using the double colon operator. For our person class, ageRef equals person double colon age gives us a mutable property reference. You can read the current value using the get method, passing the instance as an argument. This returns the current age value, which is 25 in our example. But here's where it gets interesting. You can also change the value using the set method. The set method takes two parameters, the instance you want to modify and the new value you want to set. This allows complete dynamic control over object properties. K-function provides the ability to invoke functions dynamically at runtime. This is particularly powerful when you need to call functions without knowing which one you'll need until runtime. To obtain a function reference, use the double colon operator followed by the function name. For example, double colon greet creates a reference to the greet function. Once you have a function reference, you can invoke it using the call method. Simply pass the required arguments to call, and the function executes with those parameters. In our example, funcref.call with the argument Kotlin would execute the greet function and return hello, Kotlin. This dynamic invocation capability is essential for building plugin systems, test frameworks, and any application that needs to execute code based on runtime decisions. Reflection has numerous practical applications in real-world development. One of the most common uses is serialization and deserialization. Libraries use Reflection to automatically convert objects to and from formats like JSON or XML, eliminating the need for manual conversion code. Testing frameworks heavily rely on Reflection for dependency injection and mocking. They can automatically create test doubles and inject dependencies without requiring explicit wiring code. Annotations processing is another important use case. Frameworks can read and process custom annotations at runtime to provide behaviors like validation, routing, or security checks. Finally, ORM frameworks use Reflection to map objects to database tables automatically. They inspect your class structure and generate the appropriate SQL queries, making database interaction much more convenient. These use cases demonstrate why Reflection is such a fundamental tool in modern application development. While Reflection is powerful, it's important to understand its performance implications. Reflection operations are significantly slower than direct method calls or property access. This is because Reflection involves additional runtime checks, lookups, and dynamic dispatch that can't be optimized by the compiler. However, you can minimize the performance impact by following best practices. First, cache your Reflection references. Instead of obtaining a class or function reference every time you need it, store it in a variable and reuse it. This eliminates repeated lookup overhead. Second, use Reflection only when necessary. If you can accomplish something with direct calls or compile time features, prefer those approaches. Reserve Reflection for scenarios where you truly need dynamic behavior. By understanding these considerations and applying these techniques, you can use Reflection effectively while maintaining good application performance.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.